Okay. All right. Awesome. Okay, guys. So we're just literally about to start now. Where's that sound coming from? Okay. I think there's someone who let's see. Mic off. All right. Awesome. So please, once you join, I beg mute so that there isn't sound or noise, so everyone can you know can hear. Right, right. So please, once you join, just make sure that you mute, okay? All right, we are gonna start right now, and I've already also started recording as well. This would probably, and by this I mean the recording will probably get to everyone, like say maybe like tomorrow or Monday, But let's see. But anyway, thank you guys for joining. So today we're going to be talking about the networking for cloud engineers, sort of class or course. I intended for this to be like a 4 week thing, right? So let's see how that goes. Hopefully, it's probably even less than that, or it doesn't go too far because we also need to submit our assignments as well. And I'm sure that we have our minds placed on our assignments too. So thank you so much for joining this. So networking for cloud engineers. So basically, what I'm about to teach you, I gained these insights from the CompTIA Network Plus course, not the exam. I haven't taken the exam yet, but I took the course from Udemy, right? And if in case you don't know what CompTIA is, the Computing Technology Industry Association, more commonly known as CompTIA, is an American non-profit trade association that issues professional certifications for the information technology industry. It is considered one of the IT industry's top trade associations. So basically, I pulled this off of Wikipedia, and yeah, like I said, everything I'm about to teach you is CompTIA Network Plus certified because I gained it from there. And just in case you want to go in depth, because I trust me, I'm just scratching the surface here. But in case you want to go in depth, you can take the course yourself as well from Udemy too. And this is the course. Oh, and by the way, I'm gonna this Notion board that I'm presenting on. I'm gonna share this Notion, the link to it with you immediately after the meeting. And also, to another agenda we have for after the meeting is that um, we have, I won't call it a different class, but we have a class on WSL where we would learn how to install WSL and Docker and so on and so forth like that on Windows. So for now, let's go straight into our class for today, which is class one, Network Fundamentals, OSI model, ports and protocols. All right. So today we're going to touch three major topics: network fundamentals, OSI model, and ports and protocols. So network fundamentals. What's a network, right? Networks encompass a diverse range of connections extending to both wireless networks and wired networks. Networks serve the essential purpose of connecting a multitude of devices that facilitate a seamless flow of data, right? For example, the smart watch that you wear, right, communicates with your smartphone using Bluetooth, forming what's known as a personal area network or a PAN. And the Wi-Fi network in your home connects your tablet to the internet using wireless access points, which is WAP, and that's through a local area network or a LAN. So these are networks that function all around you. You've always known them. You've probably just not really known them. Um, would I say to this extent, perhaps? Anyway, so on and so forth like that. So due to our reliance on networks, obviously, because if MTN faults you now, or Airtel goes down as you're watching this now, you definitely, I'm sure you're going to cost them. So, due to our reliance on networks, please make sure to mute once you join, okay? Thank you, thank you.
Definitely. I want to switch to sensor with my record.
Awesome. Thank you very much. So, due to our reliance on networks for connectivity and communication, high availability and uptime are important, right? Ideally, everyone demands 100% uptime, but that's not realistic, right? 100% uptime means network or IT companies would have to run their networks for years without even 1 second of downtime, right? I mean, even if you're Apple or your Google, like, I mean, that's just not possible. So instead, Most IT companies promise only 5 minutes of downtime each year, which is viewed as being ample enough, And basically, I mean, 5 minutes of downtime per year is good enough. I mean, you probably won't even tell that network has been down ever if it just goes down 5 minutes a year. So that concept of 5 minutes downtime each year in networking is referred to as the 5 minutes of availability, and it is represented like this: 99.999%. So I just thought to include this calculation here, just in case you guys were, anyone was wondering, how does this mean 5 minutes per year? Well, total number of minutes per year. So I mean, 525,600 minutes every year, each, like 365 days. When you do the calculation, multiply that. This is the amount that you get in terms of the minutes available.
Sorry, Olmo,
Yeah,
can
go
you
on.
increase your the
Fonts.
font, the
Okay,
size of the screen? Thank you.
no worries. Is this good enough?
Yeah, this is perfect. Thank you.
All right, awesome, awesome. All right, so then when you subtract the total number of minutes per year from, or rather, when you subtract the minutes available from the total number of minutes per year, then you get 5 minutes. So that's where we get the 5 minutes downtime each year thing, right around 5 minutes and a couple seconds. So the challenge for IT and network companies and network technicians, you know, such as most likely yourself, depending the kind of organization that you end up working in, your task would be to maintain this level of continuous operation day after day and year after year. And this changes depending on the provider that you're working with. Some providers I think they call it SLA. They will tell you how much time that they need. Both of you basically agree on a particular time, and then that's that'll be the challenge. You now have to work towards achieving that. So network components. What do our networks actually consist of? So clients, all right. Clients are devices that users use to access the network. You already know that. Servers provide resources to the network. Hubs, switches connect other devices, such as clients and servers, over a local network or local area network, right? Then WAPs, wireless access points, routers, firewalls, load balancers, proxy, intrusion detection systems, and intrusion prevention systems. IDS and IPS. IDS detects unauthorized access or anomalies and alerts administrators, while IPS not only detects threats but also takes action to prevent intrusion. So we're not really going to go deep into this, but I just listed the other ones because you would eventually go through this yourself. You would have this resource, so you can go through this yourself as well. So network resources. How is data moved around the network? Two main models, right? The client server model and the peer-to-peer model. Client server model utilizes a dedicated server to provide access to network resources. So basically, files, scanners, printers. I mean, it's pretty much how businesses run. For instance, upload your when you want to host your website that you've built, you buy um, server space from a web host. That is a client server model, right? So the peer-to-peer model, those of us that are like bad guys and hackers on here, if you remember when I still think it's still a thing, and that's I'm talking about Torrent Bay and uTorrent and those other torrent websites that allow you to get music that's pirated or movies that are pirated, so that you won't have to pay for anything. So that's known as a peer-to-peer model. So peers, basically peers to other machines, laptops, desktops can share resources together directly through torrents. Also, something you may or may not know too is that the blockchain technology is also a peer-to-peer model technology as well, which is the reason why it's known as decentralized. So when you're thinking client and server, think centralized data source and data distribution. When you're thinking peer-to-peer, think decentralized data source and data distribution, right? This is the leading model for business networks. This is the leading model for distributed resource sharing for global communities. Example, BitTorrent and the blockchain. Um, both of these networks. Someone is saying they can't hear me speak. Guys, can you hear me speak fine?
Yeah, we can hear you. So I think they need
Yeah, we
to
can
click
hear you.
on your image and increase the volume. They should click on your image on this call and increase
Yeah,
the volume.
increase the volume.
That
Yeah.
will help.
All right, cool. Awesome. All right. I would also try to increase my voice as well. All right, awesome. Okay. So, you can also perform like your own research in this area to learn more because there's a whole lot more here to learn, within your own time. That'll be helpful. So next we're talking network geography. So, from our smallest networks to our largest networks, there's like a geography around the whole thing. So I'm sure you've heard of PANs, LANs, CANs, WANs, and all the rest of them. The personal area network, which is known as the PAN, is the smallest type of wired wireless. I won't really go too deep into this. Again, you can read this through. You say? Okay, I thought someone said something. So you can read this through yourself when you eventually have access to this Notion board. But essentially, the PAN, which is the personal area network, examples of it are, your Bluetooth, your YouTube connection, and then local area network. These are devices that are connected in a limited distance, right? Then the campus area network, a building-centric LAN that is spread across numerous buildings in a
Okay,
certain
I
area.
learned network. I will put your phone.
Someone's audio
I'll
is
put your
on.
phone.
Someone's
I
audio.
will start your.
Thank you very much. Thank you. Okay. Um, then so for campus area networks, I think even the name, makes sense in it of itself. Just imagine, say you're in like Unilab, for instance, that's a campus area network. If they have like an open Wi-Fi that works all across the university, that's a campus area network. And then metropolitan area network basically connects campuses. So I don't know if we have it here in Nigeria, because this is our system in this our country. I mean, anyway, but take for instance the say campus of police departments. Like in the US, they are all connected, so that would be like a metropolitan area network type of thing. That's a man, and then wide area network. This is the largest one. This connects geographically disparate. I mean, this is the largest one. So here, there's an image here that sort of helps you to understand or to see the geography of the whole thing and sort of grasp you know uh, how big it is really. So I included some quizzes in here just to test as we are going along. So we're just going to run through them. All right. Again, you would have this Notion board, so you can go through this yourself as well. So, question number one, for those of you who have been listening, which of the following network geographies refers to a network that spans several buildings within walking distance of each other, such as at a business park? So, what's the answer to this one? Anyone can just, say what they think the answer is.
I think it's wide area network.
Okay. Does anyone else have an answer?
I think it's calm.
Yeah, campus area network sounds more like it
Yeah. All
because
right.
they are working within walking distance of each other, and as well
Mhm.
as a business park. Instead of business park, make that faculties. So campus area network.
All right. Cool. So I don't know what the answer is, so let's check out what the answer is. So when you click on see answer, let's see. Okay, answer is A. So you're right, campus area network. And just like you said, this goes into a brief explanation here. Why that's the answer. I'm not going to read through this completely, but you can see here it says the CAN is a computer network that spans a limited geographic area. CANs interconnect multiple blah blah blah. I'm not going to go into this, but again, you can go through this on your own as well, just because of time on here, so that we can go through everything. So question number two, which of the following type of network models doesn't differentiate between the devices that provide services and those that request services? Anyone?
Uh, let me take a shot. Point to point, because client to server will differentiate the device that is requesting and providing. Hub and spoke, same thing. Peer to peer. Uh, okay. From the way it looks, That peer-to-peer, no, it's peer-to-peer. I don't think point one makes any sense. So peer-to-peer.
Yeah, it's, let's see. Again, I don't know what the answer is, but yeah, you're right. It is peer to peer. Peer to peer again because it's a explanation. A network model that does not differentiate between the clients and the servers, and every node can become a client or a server. I mean, when you think about it, kind of like the blockchain, right? Every single computer that is connected to the blockchain is a server as well as a client. Sorry, guys, please, mute if your background is noisy. So, so yeah, that's the quiz for this. So we've basically gone through the first part. Oh, guys, please mute.
Is it possible to mute them from your end, or just make someone a co-admin so that they can do that?
Oh, I think I just did that. Sorry, it also cut you off as well, Adeze. I wish I could do the co-host thing, but almost it has to be like 3 people minimum, and I have to pay for that person as well. It's not like Zoom where you can just like add them up. So that's why I can only be the one managing this. I wish I didn't have to be the one managing this, but it is what it is.
No worries, you can go ahead.
Yeah. All right. Awesome. Awesome. So on to the next one now, the OSI model. So OSI model. OSI stands for Open Systems Interconnection Model. It was developed in 1977 by the International Organization for Standardization. The OSI model is made up of 7 different layers, right? Which we'll cover, very important. And understanding each of the layers is crucial to our understanding of computer networks. To name or label the 7 layers, we start at the bottom. We start at the bottom and go to the top. So it's important to note this. When you're naming the layers, we start at the bottom and we go all the way to the top. So this is just a view of the layer. So at layer one, right? Layer one, we have the physical layer, the data link layer, layer two, layer three, we have the network layer. At layer four, we have the transport layer. At layer five, the session layer. Layer six, the presentation layer, and layer seven, the application layer. Right now, here's a memory aid, a mnemonic to remember the 7 layers and its naming order, because sometimes it's tough to remember. So one mnemonic is please do not throw sausage pizza away, right? So if you remember, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer, right? From the bottom to the top, 7 layers. So this one mnemonic, please do not throw sausage pizza away. Check out this other one. Just in case you don't remember this one, you most likely remember the second one because the second one is fun. The second one is please do not teach students. Let me highlight it on here. Right. So this is it. Please do not teach students pointless abbreviations. So I mean, if you don't remember the first one, I doubt you forget this one. Yeah, this one is my favorite. So again, physical layer, um,
Please, can you go back to the previous abbreviation?
abbreviation. Okay. This is it. So please do not throw sausage pizza away. And something to note here is that it's counting from the top to the bottom, but don't be distracted by this because this is layer one, this is layer seven. But normally on the OSI model, it's actually from the bottom to the top. So don't let this confuse you. Um, yeah. So now networks are designed to make data flow across networks topology. And as data flows through these 7 layers of the computer network, its name changes. So we're talking about the units now, okay? As data flows from layer one to two to three, four, five, six, and seven, the units of that data change. So it's also known as protocol data units or PDUs. And for layer one, it's bits. Remember, layer one is the physical layer. So for the physical layers, computer how do I say without saying something that I do not know. Anyways, ones and zeros, bits, right? I think we all understand that. So that's physical layer bits, layer two frames, data link layer, layer three, the network layer packets, right? And then layer four segments, and then from layer five to layer seven, they are all known as data. Another mnemonic or memory aid to remember this is do some people fear birthdays? Okay, right. I think this one, I don't know, it might be boring, but anyway. So you may want to perform your own research in this area to learn more about each layer of the OSI model because there's a lot more to learn about them. That's just not the only thing. I've also added this image as well to help you. So enlarge the image below to learn more about the OSI model. Pay attention to the protocols column and understand what each layer or each protocol functions. Sorry, and understand what layer each. What's going on? Okay, and understand what layer each protocol functions at. So I'm going to zoom into this. Let's see. Okay, it goes in. Nice. I hope you guys can see this. This is the highest zoom range that I can go. So I'm going to start from the list, which is the physical, layer one, the physical layer. Here it says the physical layer is the OSI model's bottom layer. It specifies the physical properties of a medium that is used to carry data between devices, for example, voltage levels, maximum transition distances, physical connections, and so forth. Digital bits are transformed to electrical signals for wired connections and radio signals for wireless transmission at that layer. Okay, and within layer one, the TCP/IP model. So, okay, there's something else I haven't really talked about here, which is so there's the OSI model and then there's a TCP/IP model, right? The TCP/IP model, kind of like the OSI model, but what it does is that it merges certain layers of the model together. For instance, the TCP/IP model merges layer one and two into one layer, and it calls it the network access or link layer. Then the network layer 3 remains the same as the internet layer. Layer 4 remains the same as the transport layer. Then layer 5, 6, and 7 of the OSI model is merged together and is just known as the application layer for the TCP/IP model layers. So, and then these are the PDUs, like we talked about, the protocol data units with, bits, frames, packet segments, and data. And then, this is where it gets really interesting. The hardware that functions at each of these layers. So, here you have network cables, switches, and bridges. At layer 3, you have routers. Layer 3 switches. So, one something, I don't know if I should say this, maybe that's maybe giving too much detail, but there are switches and then there are layer 3 switches. Switches, normally, without the prefix of layer 3, in them are layer 2 devices. So when someone says a switch is a layer 3, sorry, a switch is a layer 2 device, but a layer 3 switch is a layer 3 device. There's a difference between a switch and a layer 3 switch. The difference is that a switch is just a switch. A layer 3 switch is a switch plus a router. So that's the major difference. A layer 3 switch is a switch. It functions as a switch as well as a router. Router being that it allows network connections to go out of the local area network into the internet. So and then here these are the protocols that are attached to each layer. So you have Ethernet, sorry, Ethernet. At layer 3, you have the ICMP protocol. We'll look at all these protocols. Good. I hope that we do have time to go through these things. And then the TCP/IP protocol. Sorry, the TCP protocol, the UDP protocol, DNS, FTP, SNMTP, and so on and so forth for layer 5 to layer 7. So yeah, again, you can kind of go through this as well on your own. So that's that. That's that for the OSI model section. So questions, right? Question number 1. According to the OSI model, at which of the following layers is data encapsulated into a frame? Anyone? Okay, so there's something that I didn't really talk about, which again, try not to give too much detail, too much, just so that we can go through the whole thing. But as data moves from layer 1 to layer 7 and from layer 7 to layer 1, there's a process that goes on known as encapsulation and decapsulation. right? Encapsulation and decapsulation. So I didn't really talk about that, but it shouldn't stop you from answering this question though, because there's a keyword in this question that should kind of point you to what the answer is. Because we touched up on this above when we were talking about the OSI model. So according to the OSI model, at which of the following layers is data encapsulated into a frame? Anyone? All right, let's check out what the answer is. Okay. So when you click the
Somebody
answer,
already responded in the chat, but it's
oh,
okay.
someone respond. Okay, sorry, because the thing is, I'm not actually seeing the chat. Like, I'm not even looking at the screen, the recording screen. I am okay. Layer two. Oh, yeah, exactly, exactly. Thank you very much. That's the answer, layer two. Thank you. That's the answer. So, it's kind of touched upon here as well. The layer two, the data layer, and why is that the case? It's because remember, layer two, the PDU for layer two or the protocol data unit for layer two is frames. So, layer data is encapsulated into a frame at layer two. So fantastic. Second question: which network device operates at layer two? Let me be looking at the chat just in case anyone posts an answer on there.
A switch.
A switch. Great. That's fantastic. That's the answer. It is a switch. All right. Awesome. Awesome. I don't need to go into the answers, but because you got it. So let's move on to the next one. So ports and protocols. All right. This is the last topic. This is probably hopefully where it gets one. So what is a port and what is a protocol? A port is a virtual entry or exit point for communications used by software applications to exchange information. Right. We're going to understand a lot more, beyond just this voluminous definition. What's a protocol? A protocol is a set of rules and conventions for data exchange between network devices, right? So digging deep or deeper, um, network ports fundamentals. So when we transfer data over our networks, right, we have to find a way to tell the data where it's going. So it's kind of like if you ask someone to come and visit you at your house, you need to kind of tell them beyond just asking them to come to your house. Say you want them to come to a specific room, you have to tell them exactly where to go to find you. So we use IP addresses to get data to the right system. But how does the data know what application is listening on that particular system? So to make it easier to understand, imagine you tell someone the address of your home, but you also need them to access a specific room within your house, right? For them to access a specific room within your house, you need to tell them the specific room number. You need to tell them the specific room number that they can access. Okay. Now that's what ports are to IP addresses. So the same way you need to tell the person that accesses your house, maybe you need them to deliver something. Just imagine this kind of houses where your home address is not just the house itself. Maybe it's like a flat, and you need to tell them that you stay at flat 52 or something. So if you just tell them the house, they won't still find you. You need to tell them the flat number. So that flat number is to your house or to your room what ports are to IP addresses. So I hope that helps in understanding ports. So it's a kind of room or room number within a house address. Okay. In other words, a port can also be referred to as a logical opening in a computer that represents a service or application. In computer networks, in computer networks, all ports are numbered from 0 to 6,535. This number is a very interesting number. We're going to come back to this number. I don't think it's in this class. I think it's next week if we have this class again next week. But the next class we would have when we talk about IP addressing, we will come back to this number because it's a very interesting one. But all ports are numbered from 0 to 6,535, meaning even though you have only one IP address for your machine, you can have 5,535 openings for different services and applications to run on. So yeah. Let's not deep down before we waste time. So ports are categorized in three. Well-known ports, which are from 0 to 1,023. Registered ports, which are from 1,024 to 49,151. And ephemeral ports, which are from 49,151 to 65,535. So just to kind of understand what these ports are, well-known ports are like standardized ports that exists. So, for instance, the web port, web access port, which is port 80, the SSH port, which is port 21. Those ones are well-known ports. They are standardized, right? So, for instance, you cannot build your own application and say, I want to go and take up port 80 because it won't work. Because the Internet Assigned Numbers Authority, IANA, funny name, would not actually allow you take on that port number because they're the ones that authorize these things. It'll be fun to work at a place like that. Anyway, and then registered ports, are reserved or privatized ports authorized by them. So let's see. Say for instance, you open up a company, say like a gaming company, for instance, and you want um, to reserve a particular port for your application. You would speak to these guys and tell them that you want a particular port, and then they will make that port available to you, and that port will now become your own. But that port can only be available within this 1,000 to 49,000 range. So those are registered ports. Now, ephemeral ports, no one owns these ones. These ones are free for all, right? They are short-lived temporary ports which are opened for just a small period of time from a predefined range of ports. This predefined range of ports. So moving on from there, what does this look like in the real world? Let's take a look at the image below, right? Check out this image. So in this image, we have like our client device. Let's call this my client device. Then we have the website server, right? My client device has a source IP of 192.168.1.24, and the website server has has an IP. Let me not call it destination IP, but has an IP of 64.82.46.21. And as you can see here, we are making a GET request to this website server, and the GET request is coming from my IP. It's also coming from a source port of 49,163. Now, 49,163 happens to fall under this ephemeral port. So as you can imagine, what's happening here is that my client device is picking a free port within the ephemeral ports range so that it can communicate with this website server, right? And now when it does that, it gets the information from this website server. This website server now sends the information back to my IP address to exactly this destination port. And once that communication is closed, once my client's device has gotten the web files from the website server, this port is closed. Or you could say this port is delisted. Like this port would no longer be in use anymore. Then when there is another request from my client, it will now pick another port, a new port. It could pick the same port, but basically it's picking ports at random. So that's everything I just said now is kind of what I explained here. I don't know if I have to go through this, but it's explained here. So you'll understand it once you read it. So here it says the website server will receive the GET request from the client and respond with the files or data from port 80 back to my client source IP 192. Blah blah blah, and to the random port number this, right? So that's how I'm able to open the website on my browser and view its contents. And once the connection is done and file transfer is complete, my client device will close down or delete that random port it generated. This random port, it will close it down and delete it. So this is an example of an ephemeral port. So why does it do this? Because that port was an ephemeral port. In the next session, by the way, a session is when a connection has been made between two different devices. When a connection has been made, you're now in a session. So in the next session, a connection from the same client will be sent to port 80, but we'll use a new ephemeral port. So yeah, hope that explains that. So moving on to TCP. TCP, Transmission Control Protocol. Again, we are in, what topic are we at right now? TCP, what topic? Okay, ports and protocols, right? Ports and protocols. So we're now talking about the Transmission Control Protocol, TCP, within ports and protocols. So TCP is a fundamental protocol within the Internet Protocol suite that consists of a set of rules that govern the exchange of data. TCP is widely used due to its reliability in delivering packets of data across the network because it can ensure that all the data packets reach their intended destination in the correct order and without corruption. It's important to note these three things. TCP operates at the transport layer of the OSI model. Remember, we looked at the OSI model, and at the transport layer, which is the transport layer is a fourth layer. The layer below that is a network layer, right? And then TCP functions at the transport layer of the OSI model. Okay, because remember, did we actually specify it here? I'm not sure we did. Anyway, TCP is used to transport or transmit data. That's why it exists here at the transport layer. So when you think of this TCP, think of the what they call three-way handshake. So this three-way handshake is explained with this thing called SYN, ACK, and ACK, right? Now, this handshake is used to establish a connection between two different systems. So basically what happens is, again, if I go back to this, example. So my client is trying to get web files from a web server. It sends a GET request. But when it's doing that GET request, it needs to sort of it needs to confirm that there's a connection between my client's device and then the web server. The way it confirms that connection is through TCP, TCP, and it does that through the three-way handshake using SYN, ACK, and ACK. Now, what this means is that it synchronizes. Then SYN, ACK. Now, basically, I kind of go into depth on it here, Sha, but actually, no, let me just move on to this because I'll say this and I'll still go back to saying this again. But synchronize, basically here, the client sends a SYN packet to the server to initiate a communication session. Then SYN ACK, synchronize, acknowledge. The server will then respond with a SYN ACK packet to acknowledge receipt of the SYN packet and to inform the client that the server is willing and able to establish a session. Then at the ACK stage, finally, the client sends an ACK packet back to the server to confirm the establishment of that connection. So when you're looking at this thing visually, there's usually like this zigzag image. I wanted to include the image here. I'm not sure why I did not do that, but there's like this zigzag image that depicts the connection flow as it goes from the client to the server, SYN, then server back to the client, SYN ACK, and then client back to the server to say, okay, I'm going to go on and start sending you requests now. So this three-way handshake process ensures that both the server and the receiver are ready for data transmission and that the communication channel is reliable and secure. Now, if you notice something about the transmission control protocol, the TCP ensures that there is a connection. Remember these three things that we noted here. It ensures that there is a connection before it goes on to send data. Okay. Now, UDP, User Datagram Protocol. Now, UDP is a communication protocol used across the internet for especially time-sensitive transmissions such as video playback, video gaming, or DNS lookups. UDP is known for its low latency and reduced processing overhead, but it lacks the error checking and recovery services of TCP. For these reasons, UDP is ideal for applications where speed is critical or error correction can be handled at the application level, or is considered to be non-essential for a particular use case. For instance, when you're gaming now, like when you're streaming movies online, you don't really like there'll be packets that will be lost. For instance, if you notice as you're streaming movies, or like if you're watching a live stream, for instance, there'll be times when there'll be this glitch, not that it would stop playing, it wouldn't stop playing, but there'll be this glitch. That glitch is because there has been a packet loss, but it just keeps feeding you data packets because you wouldn't really mind because you're not really concerned in that particular use case whether or not there's an error and to check that error. All right. So this has certain applications like we've mentioned here, video playback and video gaming. So UDP operates also at the transport layer, same as TCP of the RSI model. Now the difference between TCP and UDP is that where TCP required a three-way handshake to establish a connection between two different systems, UDP does not and only sends data packets, also known as datagrams. Memorize this, datagrams to the recipient without prior communications to set up special transmission channels or data paths. So because of zero to no or low overhead in UDP connections, UDP data packets or diagrams are much simpler and smaller in size compared to TCPs. So you can understand now why UDPs are used for video playback and streaming, because if TCP was used, that video will not play. Do you understand? It won't play. And another good example is DNS lookups. So DNS lookups, for instance, if someone tries to search for your website, obviously, then they will now use the DNS service. If it's taking too much time, your website will not load, and so on and so forth like that. So these are applications of TCP and UDP, and there are different use cases for them. So the next one, the internet control. What's going on? All right. So the next one, the Internet Control Message Protocol, or ICMP. Now, unlike TCP and UDP, ICMP as a protocol is not used for transporting data between two different systems. Instead, ICMP is used to diagnose network connection issues and provide info on network problems. So, notice the difference, right? TCP and UDP are transport data protocols, but ICMP is not a transport data protocol. Instead, it's a diagnostics um, data protocol, you could say. It's used to diagnose network communication issues and blah blah blah. So ICMP functions at the network layer of the OSI model, not the transport layer now. So you see, ICMP is an essential tool for error reporting and testing. An example of ICMP that you probably didn't know, but you've been using it, is the ping network command utility, which uses ICMP to send ICMP echo requests message to test the reachability of a host on a given IP network. You guys should stay with me here because we're about to go through a huge read. Okay. The receiving host, if they're available and functioning properly, will then respond with an ICMP echo reply after the ICMP echo request has been sent, right? Now, this utility is widely used to check network connectivity, and it ensures the round trip time. Or rather, it measures the round trip time, which we call latency of the network connection. ICMP lacks the reliability mechanisms of TCP, but prioritizes speed and simplicity over data integrity and security. So ICMP is not secure. For this reason, hackers have used this protocol in the past and still do to perform network attacks on computer systems. So two known network attacks that exploit the ICMP protocol are the ICMP flood attack and the ping of death. Now, the ICMP flood attack is an attack that involves overwhelming a target machine with a large number of ICMP echo request packets. This leads to something called a denial of service (DOS) attack, or distributed denial of service (DDoS) attack. I'm sure you've probably seen this somewhere. When the request traffic packets are sent from distributed computer networks, usually a network of compromised computers known as botnets. So this ICMP flood attack, leads to like DOS attacks. Basically, what happens is that when the hacker is flooding a particular server or computer with too many ICMP echo requests, like too many than it can respond to, it now freezes or glitches. And once it's done, like when it freezes or glitches or goes down, the hacker now has time to do what he needs to do, or maybe that was his goal all the way from the get go, was just to make the system go down. And if it's a financial system, you can imagine then they'll lose lots of money and so on and so forth like that. So that's the ICMP flood attack, DOS and DDoS as well. Now, the ping of death is a type of attack that exploits a vulnerability that existed in older unpatched systems where the attacker sends malformed or oversized packets using the ICMP protocol. Okay, so you can go and go further down into these. They're really really nice. We only have 10 minutes left. Wow. Okay, so web ports and protocols. I'll try and be really quick now because we need to finish this. I hope we do. Web ports and protocols, right? So there are two main web ports and protocols. You probably already know this. Port 80 HTTP and port 443 for HTTPS. Port 80 HTTP, the Hypertext Transfer Protocol, is an application layer protocol that enables plain text communication between clients and servers. Then HTTPS is basically the secure version of that, right? As you know, HTTP is not secure. This means if you input sensitive data like your password or login, like your password on a login form of an unsecured website prefixed with http://www and so on, any hacker can listen into that network and read your password input exactly as you wrote it. So obviously that's not safe, and I'm sure we kind of know this already. HTTPS encrypts the communication tunnel between your client's device, that is your laptop, and then the server where you're signing in or inputting your password into. Websites today auto direct users from HTTP to which is unsecure to HTTPS, which is secure, for enhanced data encryption and security. If you've done digital marketing, you will know that SEO requires HTTPS. If your website is not SEO enabled, you dey play oh, your website will not rank on Google. So yeah. Anyway, but that's that. Then next, email ports and protocols. So some email ports, that help some email ports and protocols that help us to send emails and receive emails are known as SMTP, POP3, and IMAP. So SMTP stands for Simple Mail Transfer Protocol. This is basically the protocol that helps us to send mail. So when you send, every time you send a mail, that mail goes through port 25. Well, if any no anyway, that mail goes through port 25. I don't want to talk about SMTPS because I didn't include it here because I'm trying to be quick. So when you send a mail, it goes through port 25, the SMTP protocol. Um, it is primarily for sending mails. Now, if you want to retrieve or receive mails, these two protocols are the protocols that you use. You either use POP3, I don't think anyone uses that today anyway, or the IMAP protocol. Most people use the IMAP protocol. And the reason is because with the POP3 protocol, it's designed to download messages from the server to the email client and then delete those messages from the email server after they were downloaded. So the way POP3 works, it was the first protocol. It was the earliest mail transfer protocol. So um, once you've downloaded the mail, it just deletes the mail from the server itself. Obviously, that's not how it works today. Today, instead, when you view your email and you click like that you've read it, it will synchronize to your server. And the next time, if you open that same email on a different device, it will also still show that you have read that mail. So that's what IMAP does. So unlike POP3, IMAP, with IMAP, you can access and synchronize your messages across multiple devices as long as you have an available internet connection. So what's allowing you to do all of that and have that much fun is IMAP. Now, these are unsecure protocol transactions, or yeah, protocol transactions. So each of these protocols, they have their secured versions. I'm not talking about them here because it would, this will go too deep. But you can go and go on and study these for yourself. SMTP, POP3S, and so on and so forth, like that. So next, file transfer ports and protocols. Okay, there are three main or rather four on here. Four main ones. There are a couple other ones as well, but four main ones. And they are FTP, SFTP, TFTP, and SMB. So FTP, you're talking the file transfer protocol. So if you've done WordPress development before, you definitely know FTP. And this goes on port 20 and port 21. Port 20 is used for actual data transfer. Port 21 is used for sending control commands like I want to upload this particular file or I want to download this particular file. Right? FTP is not encrypted, right? It's sent in plain text, and that is where SFTP comes in. It secures is like secure, file transfer protocol. Now SFTP is sent on port 22. What else lives on port 22? SSH. So SFTP is basically files that are transferred over the SSH protocol, right? Right. The trivial file transfer protocol of TFTP is like an earlier version of FTP, right? I think that kind of explains itself. Server message block (SMB) allows applications on a computer to read and write to files and request services from the server programs inside of a computer network. Now, this operates over port 445. I highlighted them for you on here. SMB is predominantly used for Windows sharing. It's a Windows created protocol. It's mostly used for Windows file sharing, and it allows Windows computers to communicate with each other and share files over a network. Right. So let's see, where are we now? Okay, second to last. All right, awesome. Remote access ports and protocols. So within remote access ports and protocols, here you're talking things like SSH, Telnet, and RDP. Right. I'm not going to read through this, but you would read through this on your own. You already know SSH port 22. Just in case you do not know SSH, SSH is a protocol used for secure remote login and other secure network devices over an unsecure network, right? It's used to secure your operations over an SSH connection. Sorry, to secure your operations over an SSH connection, SSH creates a secure encrypted tunnel that can operate text-based commands from a remote server. Now, Telnet is the unsecured version of SSH, right? Telnet functions at port 23, and because it's unsecure, it lacks encryption. It's advised not to use Telnet for security-dependent operations. Okay. Now, the other remote access ports and protocol is Remote Desktop Protocol (RDP). If anyone has used VMware, not VMware for virtual machine creation, but VMware to access a computer somewhere else, or if you've used AnyDesk, if anyone has used AnyDesk here, or what's the name of the other one? TeamViewer, I think. So if you've used TeamViewer, AnyDesk, or any one of those ones that allow you to control a system somewhere else from your own system, like you can view the GUI, the graphical user interface of a different system, then that's RDP, right? That the port that's allowing you to do that is RDP, and it's mostly it was developed by Microsoft. So is Tony here? I hope Tony is here. So you'll be seeing everything that Windows Windows people are doing. Mark just went and decided to take Linux and just say, we don't even want to stress ourselves. So let's just take the one that's working. Anyway, on to the last section here, and this is actually the most important section, because this is the one that touches cloud engineers, right? Networks, network service ports and protocols. So, okay, I have 4 minutes. All right. So network service ports and protocols are fundamental to the operation and management of our modern networks. Our modern networks comprise of different services that ensure that network devices can discover each other, right, communicate efficiently, and relay important system information to each other. Okay. Um, Network service protocols that enable us to do these things are protocols like DNS, DHCP, SQL services, SNMP, and syslog. Now, DNS, domain name system, is used to translate human-friendly domain names into an IP address that computers can use to identify each other on the network. All right, and this operates over port 53. Right now, DNS is unique because it operates on two different transfer protocols, which is TCP and UDP. Now we have DHCP, which is used to automate the assignment of IP addresses, subnet masks, gateways, and other networking parameters to a client device. So this automation simplifies the process of configuring devices on IP networks. So DHCP, the DHCP protocol is a protocol that automatically, like, there's a reason why once you turn on, there's a reason why once you connect to a Wi-Fi with your phone is quickly just able to access the internet. We'll definitely go beyond 7, maybe like 5 to 10 minutes beyond 7, but I was hoping that wasn't going to be the case. But please bear with me. There's a reason why once you connect your phone to Wi-Fi, it automatically accesses the internet, because there's an automated system that allows that happen. If there wasn't an automated system, if you connect your phone to a Wi-Fi, you would have to manually assign your phone a local area network IP. We will talk about this next week when we talk about IP addressing. You would have to like manually assign yourself that IP address so that you can now access the internet through that Wi-Fi. But thankfully you don't have to do that, and that's because DHCP is doing that for you. Okay, so that's the dynamic host configuration protocol. So that functions on port 67. SQL services, protocols that allow you access SQL database services and manage queries and control operations on databases. Um, the thing with SQL services is that there isn't a single standard port for all SQL services, because different providers who make different SQL servers have chosen to use different port numbers. So, but the two most common SQL server providers are to be aware of are Microsoft's SQL Server and MySQL. Microsoft SQL Server I think that one is proprietary. I think it's proprietary. It's not open source, but MySQL is open source. I think so. I'm not sure. Microsoft's SQL Server operates over ports 1433, 1433, and then MySQL Server operates over ports 3306. SNMP, the Simple Network Management Protocol. So this is used for collecting information from and configuring, different network devices like servers, printers, hubs, switches, and routers over an IP network. Basically, what this does, by the way, it also functions over two ports, 161 and 162, and it uses the user diagram protocol as well. So what this does is, let me just read this. If you are curious what SNMP is used for, it's crucial for network diagnostics and performance monitoring. For example, AWS CloudWatch and CloudTrail use SNMP under the hood because they pull information about who is using what on that, on their servers, and you can use them to monitor server diagnostics and measure performance metrics and so on and so forth like that. So all that is SNMP. Then syslog or system logging is a standard for you know message logging that allows devices to send event messages across IP networks to an event message collector known as a syslog server. This is how you can read logs. DevOps, you'll be reading logs all day long. So this is the port that allows you to do that, syslog. It operates over ports 514 using TCP or UDP depending on the use case. So that's that. But before we end though, let's take a quiz. Wow. God, I feel like I've been blabbing for a while. Okay, so guys, we're gonna take questions now. So I hope you've been following. I hope you've been following. So question number one: what protocol is commonly associated with port 53? Anyone?
The comment section said TNS.
DNS. Awesome. That's it. That's the answer. It is DNS. Great. Oh, and by the way, just in case if you arrived here later, you can always click that see answer and you will see the answer as well as the explanation here as well. And this document is going to be sent, the link to it will be sent to everyone. So question number two, which protocol is connection oriented and ensures reliable data delivery by establishing a virtual circuit between sender and receiver? Any message in the comments?
I think TCP.
TCP, yeah? Let's see. Right, TCP is the answer, number one, or rather A. Answer is A. Awesome. Question number three, which statement accurately describes characteristics, God, if I can pronounce, which statement accurately describes characteristics of a UDP connection? You guys will have to think through this one. Is it A or B, C or D?
Let's see.
C.
Nice, nice. That's true. The answer is C. Awesome, awesome, awesome. So question number four, which port is commonly used for receiving emails from a mail server?
Four four three.
Mail server? Oh,
25.
no, not 25. There's one more. Is so it's not
What
C
was
and it's
for
not D.
DSL?
Yes, exactly.
And port 80 is for HTTP.
Exactly. So those two are removed.
So it's either 25 or 110. I'll most likely go for 25. Not sure.
Okay, so let's see what the answer is. I don't know it either. So the answer is B, which is 110. Okay. So maybe this time let's actually read the explanation. Port 110 is commonly associated with POP3, the Post Office Protocol version 3 protocol, which is used for receiving emails from a mail server. Port 80 is typically associated with HTTP, not email protocols. Port 443 is commonly associated with HTTPS, HTTP secure, and port 25 is commonly associated with SMTP. So I think that was where that was what confused you guys, because this is for sending emails, not receiving emails. Remember, I sort of touched upon it briefly. SMTP, the Simple Mail Transfer Protocol, is used to only send emails. every time you send an email, it goes through port 25, which is the SMTP protocol. But every time you receive an email, it either goes through port 3 or IMAP. And the one you most likely use is IMAP. As long as every time you view like an email, when you view it on a different device, it synchronizes. Like it doesn't tell you haven't read this email or deletes the email. It tells you you've read it because you're using IMAP. So last question, question number 5. Which port and protocol combination are commonly associated with Remote Desktop Protocol or RDP? Oof.
A.
Which one? A?
Yeah.
Okay.
Either A or B because I know 3389 is an RDP protocol. So
Mm, yeah.
either A or B, but I'm going for A.
Okay. Let's see. Let's see. Right. So the answer is B. So let's see why. RDP, Remote Desktop Protocol, primarily uses TCP, not UDP. So just a brief recap. Remember, we said TCP ensures that there's a connection, right? But UDP, so there's this there's a short, there's a sort of keyword that is used to differentiate between TCP and UDP. TCP is known as a connection full protocol, while UDP is known as a connectionless protocol. So what that means is that TCP ensures that there's a connection before it begins to transfer data packets. But UDP just sends, it's just blowing the connection everywhere. Like it's basically just sending data packets to the to the IP address, and it's saying, Omo, if you like, open it. If you like, don't open it. That one is your business. Me, I'm sending my own share. That's what UDP is doing. You get, but TCP makes sure it's like that class prefect. It's like a daisy, really, basically, that makes sure that everybody is on point and is following up with the class. That's TCP, and that's the reason why TCP is reliable in this case because with remote desktop protocols, which when you need to access a computer somewhere else, you need to make sure that you have connected to that computer before you can pass data between the client server and the host server. So that's why it's TCP and not UDP, and that functions like you said at daisy on ports 3389. So this part here just goes on to explain the other parts that we didn't actually, that is not the answer. We didn't actually talk about this, but this is another protocol, session initiation protocol, SIP. We didn't talk about that because that's a little bit more advanced. It's used for VoIP, voice over IP address. So when you call, like when you're calling people via WhatsApp, that's VoIP. And when you call via WhatsApp, it uses, these two ports, and this protocol uses the UDP protocol, not TCP. I think I'm not sure. I'm not sure. I'm not sure. Let me not say what I do not know. So yeah, that's that. Wow. So we've come to the end, and yeah, awesome. We went 8 minutes beyond the time. I was hoping that I would actually finish this whole thing within an hour, but it's good we finished it nonetheless. So next week we'll then go on to talk about Ethernet switching, network devices, VLANs, and MTU. MTU is short for uh, maximum transmission units. So that's when you talk about frames and jumbo frames. This is at layer 2. And then we'll talk about IP addressing, IPv4. This is the best. This is my best section. Sincerely, like throughout the whole networking thing, when I was going through the course, this is the one that I enjoyed the most. Because funny thing is that this once you learn this, even if you don't learn anything else about networking, you're fine, you're good. Because this is where they talk about you know IP addresses, CIDR or CIDR notation, slash notation. Like, for instance, if you've seen an IP address that has something uh, like 192.168.0.1 slash a number, you'll understand what that means, right? And then we'll talk about subnetting by hand, and IPv6 addressing, and then routing as well, routing tables and NAT and PAT. So thank you so much for joining this call, and I'm gonna stop sharing my screen now.
Thank you so much. Why will you stop sharing? You should be switching screen to the one you want to teach us. Thank you very much.
Okay, so what's gonna happen is that I'm gonna end this meeting because I want to end this recording. So I'll end this, and then I'll start up another meeting. I'll send the link to the group so that we can just join. Come back on. It won't take more than 2 minutes, yeah, so that we can then hop on up
Okay,
on the
that's okay.
WSO. Yeah. Yeah, like you said,
Okay.
Tunde, IPv6 no be child's play. Like that one, don't worry. Yeah, don't worry. Adeze, thank you so much. Thank you so much, everyone, for joining. So I'm gonna end this.
Okay,